Hi! For today's video, we're going to tackle about ionic bonding. But first, let me introduce myself. I'm Jamlyn Galit of 11th STEM Franklin. So, to start our discussion, let us define what is the ionic bonding. So, ionic bonding forms when a metal transfers electrons to a non-metal element.
Ionic bonding is the complete transfers of valence electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions. In ionic bonds, the metal loses electrons to become a positively charged, or that's what we call cation, whereas the nonmetal accept those electrons to become a negatively charged, or what we call an ion.
Now, let us know some elements that is in metal and non-metal.
In metal group, we have aluminum, calcium, lithium, and beryllium. And in nonmetal, we have bromine, carbon, chlorine, fluorine, hydrogen, nitrogen, oxygen, phosphorus, sulfur, and iodine. The metals aluminum, calcium, lithium, and beryllium, their role is to tend to lose or give electrons. And for the elements of bromine, carbon, chlorine, fluorine, hydrogen, nitrogen, oxygen, phosphorus, sulfur, and iodine, which is a nonmetal, their role is to gain or accept electrons. In the periodic table, we can see that all in the blue colors are all metals, and all of them are tend to lose and give electrons, while in the yellow color are non-metals, and they tend to gain or accept electrons, except to the noble gas that has already 8 electrons. So, let us give some example. So this element is lithium, with the symbol of Li. Lithium has a valence electrons of 1, and this is the example of metal. So, if it is a metal, lithium should lose electron to be like helium, because full valence shells are more stable states and all noble gases have full valence shells. So alkali metal lose one electron to achieve the nearest noble gas configuration, but beryllium is exceptional because of its small atomic and ionic radii. We can know the valence electron based on their respective groups. In the periodic table, we can find the lithium in the column of 1A. This is the 1A and 2A. And the opposite is the 3A, and so on and so forth. So lithium is in the 1A. We can identify it too by its electron configuration, the last number of electron of its orbital. For lithium, we have 1s2, 2s1. Since the last number of electron of its orbital is 1, then its valence electron is 1. Next is Cl, symbolizes the chlorine, and it is example of non-metal elements. Since it is a non-metal, it should be gain electron. Chlorine has a valence electrons of 7. In the periodic table, we can see that chlorine is in the 7th group, and we can see in this electron configuration that its valence is 7. Because the last energy level is same, so means you're gonna add their electrons in orbital. Since 2 plus 5 is 7, then its valence electron is 7. So, we have lithium with its valence electron of 1. The electron configuration is 1s2, 2s1, while the fluorine has a valence electron of 7. The electron configuration is 1s2, 2s2, 2p5. Since lithium is a metal, then it should be give its electron to a non-metal. which is the fluorine. Fluorine needs to accept the 1 electron to have 8 electrons to apply the octet rule. Then, lithium can be written as Li positive and for fluorine is F negative, and it's become lithium fluoride. Now, we have magnesium with the valence electrons of 2, and its electron configuration is neon combined with 3s2, while the oxygen has 6 valence electrons, and its electron configuration is 1s2, 2s2, 2p4. Since magnesium is a metal, it should give its electrons to a non-metal element, which is the oxygen, to fulfill 8 electrons to apply the octet rule. So, it is the magnesium and oxygen now. The electrons of magnesium was given to oxygen. Then it will written as Mg2 positive because it gives 2 electrons, and oxygen will written as O2 negative because oxygen received 2 electrons, and it will become magnesium oxide.
That's all for today. Thank you.